All right there. Hi guys. My name is Wilfred. I'm a senior math tutor, and I'll be covering 8 questions today from calculus and also a bit of vectors, I think. Oh, sorry, no, a bit of integrals. A little backstory about myself. I graduated from my master with a major in biochemistry and a minor in mathematics. And if you have any other questions regarding your mathematics problems or calculus problems, please submit them through OneClass. Okay, so let's just begin with the first question. So the first question reads, find the partial derivatives of the function z equals x. Oops, where'd my question go? Find the partial derivatives of the function z equals x sine x of y. So when it says partial derivatives, you guys can notice here that our function here is actually consisting of two variables, right? We have what's going on? Why is my computer like this? Okay, so we have a function here, function z, which equals x times sine of xy. Okay, so you can see here that our function z is a function of two variables instead of one. So deriving in terms of one variable is what we call a partial derivative in this sense. So we keep the other variable as a constant and we derive for the other variable. And what that does, it tells us the rate of change of that variable when the other variable is constant. So how you partially derive is you can write what we say dz of dx. So you notify to the reader that you're deriving in terms of x, and you're keeping y constant, okay? And all the other derivative rules applies, the power rule applies, the product rule applies, the quotient rule applies, everything else applies, except the fact that you keep the y variable constant, okay? So let's first of all do the partial derivative in terms of x, okay? So here we can see here that we have a product rule because we have x times sine of xy. So we're going to derive the first function x and keep the second function constant or the same, and then we're going to do a plus sign and we're going to derive the second function and leave the first function the same, okay? So this is what we're going to get. So if the first function is, we're going to leave the first function underived, I guess you can say, and we're going to derive the second function, okay? So d of dx of sine xy, okay? So we're going to derive the second function, and then we're going to sum them to the derivative of the first function, so d of dx of x times sine xy, okay? So what we get here is x times, so the derivative of sine is cos, so cos xy, plus the derivative of x by itself is 1, so 1 times sine xy. So that's the partial derivative of our function z in terms of x, okay? So you see here that we ignored y entirely and left it as a constant. And our partial derivative of y will be more clear what we mean by constant, okay? So let's do the partial derivative in terms of y now, okay? All right, so this time we have a chain rule, right? We have a function within a function, okay? So our chain rule suggests that we derive in terms, we set a function to be equal to u, and then we derive in terms of that. Okay, so let's say that u equals x times y, okay? So we have dz of du. So I'll just write a note here. Let u equal x times y, okay? So if u equals x times y, we have dz of du of sine x sine u, x times sine of u, and then we multiply that to du of dy of xy. Okay, cool. All right, so the first outside derivative would be, so the derivative of sine is cos, and we leave x to be a constant. So we assume that's like a number, right? So with any other constant, we just keep it the same. So this would be 4 cos u. And the derivative of xy would just be x. So, oh wait, why do I write 4? It should just be x. This x, this should be x. Okay, cool. So we're just going to sub back in our u here now. So we have x squared cos of xy. Okay. So you see here that we kept this x here and this x here constant, right? We didn't change anything. We didn't get rid of it, but we treated it as a constant. So this is how we do the partial derivatives of x and y. And this works for any multivariable function. And as we go deeper, you can also, for the second derivative, you can do a mixed derivative. You can do two partial derivatives of the same variable. You can do a lot of things. So, okay, so the junior tutor also did the solution. They partially derived in terms of x. They used the product rule, the power rule, and for the partial derivative of y, they used the chain rule with also some trigonometric identities and trigonometric derivatives. So this solution is correct. Cool. Okay,